In this video, we're going to be learning about big O notation, which gives tight upper bound for function. Big O notation can be defined as, we say that Fn is big O of Gn if and only if there exist constants C and N naught such that Fn is less than or equal to C dot Gn for every n greater than equal to n naught. Now this can be shown graphically as, let this side be time complexity and this side be input size. Then the Fn and Gn are two functions which have any behavior up to a point n naught. After n naught, Gn is always above Fn. So this n naught is the point after which behavior should not change. And we have to find a constant C such that Fn is less than equal to Cgn for n greater than equal to n naught. We have to find a pair C n naught. And if we can find a pair, many of such pair exist, we only have to find one. If we can find such one, that means that Fn is equal to big O of Gn. We'll use this definition to solve some questions. Fn is equal to 5n square, Gn is 4n square, and we have to check if Fn is equal to big O of Gn. We assume that Fn is equal to big O of Gn. Fn less than equal to C dot Gn using the formula. So Fn is 5n square, C is C, and Gn is 4n square. We can write as C is greater than or equal to 5 by 4. We can choose any C value based on which we will get an n naught value. C is greater than 5 by 4. Let C is equal to 2. For C is equal to 2, 5n square is less than equal to 2 dot 4n square, or 5n square is less than equal to 8n square. We have to find a value of n for which this will be satisfied. We can find many values. It will be satisfied for n naught is equal to 0, n naught is equal to 1, but we need only one pair, and that pair is, C and n naught pair is 2 and 1. Since we found one of such pair exists, hence what we assumed in the starting was true, and Fn is big O of Gn. 5n square plus 6n plus 3 is big O of what? 5n square plus 6n plus 3. When we ignore constant factors, it will become n square plus n, and when we ignore lower order terms, it will become n square. So we can say that it is big O of n square. But now we have to prove it. 5n square plus 6n plus 3 is less than equal to 5n square plus 6n plus 3. Both of them are equal. But it is also less than or equal to 5n square plus 6n square plus 3n square. This one, it would be less than this one because we are using n square terms with all of the coefficients, which would be less than equal to 14n square, which is what we wrote here. What we did was, we took the highest order term, which is n square, and we made every term as the highest order term so we can add. When we added, we found 14n square. Condition for big O was Fn is less than or equal to C dot Gn. Now we can see that this 14 can be written as C. Now for C is equal to 14, and we can take any term, say n naught is equal to 0. Found a pair 14 and 0, hence what we assumed earlier was true. 5n square is big O of n square. And not only n square, since it is less than or equal to n square, it means that we can take here any other thing which is greater than n square. So we can also write that 5n square plus 6n plus 3. Here we have written big O of n square. It is also big O of n cube, big O of n to the power 4, big O of n square log n, anything which is bigger than n square. However, these are all true, but we'll always choose tightest upper bound, and tightest upper bound is n square. Hence the answer to this question would be n square. Fn is 5n cubed, Gn is 6n square, and we have to check whether Fn is big O of Gn. Assume that Fn is equal to big O of Gn, and using definition then Fn would be less than or equal to C dot Gn. So 5n cube is less than or equal to C dot 6n square. For every n greater than or equal to n naught, we can cancel out n square. 5n is less than or equal to C dot 6, or n would be less than or equal to 6 by 5c for every n greater than or equal to n naught. Here n is less than a constant, not n greater than a constant. This and this are at contradiction with each other. It is saying that value of n must be less than something constant, and this is saying must be greater than something constant. This means that we cannot get a single pair of c and n naught, and since we cannot get a single pair, our assumption was false, and Fn is not equal to big O of Gn. In the next video, we'll be discussing big omega in detail.